So, hello, welcome everybody, and thanks for joining us again in this webinar of the CCAM. So, my name is Roberto Martini. I work in a team part of the Telecom. On the team, we are one of the partners of the 5G CARMEN. Today, we are here for our third webinar. So, if you have missed the first two, please go on our website. You will find links at the end of the presentations, or you are probably already arrived here thanks to our social channels. So you can easily find the links to the previous webinars that have been recorded and are available in our website and in our YouTube playlist. So 5G CARMEN is a project, a European project that is part of the Horizon 2020. Its goal is to demonstrate how to use with live network some use cases of cooperative and automated cloud. Some advanced use case where we show how 5G can help in making the future of autonomous driving. It's a pretty large consortium that involves big players of both the telecommunication and automation world, and also has the help of important research universities and groups. As I said before, we have already provided two different webinars in which we have showcased the use case that we are going to show for our own. The first use case is cooperative and automated lane change maneuver, while the second one is cooperative and automated lane maneuver. So in both cases, we are using 5G to allow to help in have autonomous driving of cooperative maneuvering. The first case is for lane change, the second one for these use cases will be demonstrated in the corridor that connects Bologna to Munich, so through Italy, Austria, and Germany. In order to deploy this use case on field using radio network, we had to come up with a pretty complex architecture that spans throughout the three different operators, so that needs to put together the work of different entities. You see here the architecture that we came up. It's not my intention to explain it now. You can go back on the previous webinar to have more information. As you can see, there are a lot of elements that need to be put together, and a lot of technological enablers that we have put in place and deployed in our 5G CARMEN platform. Today, we will focus in particular on one of the most important elements, I would say the living heart of the platform itself, that is the edge orchestration platform. To do that, I have the pleasure today to have the help of Nina Slamnik-Kriestrat. Nina is a PhD researcher in the field of applied engineering science at the University of Antwerp and in the IMEC Research Center in Belgium. In 2016, she obtained a master's degree in telecommunication engineering at the Faculty of Electrical Engineering in the University of Sarajevo in Bosnia and Herzegovina. She authored and co-authored several publications and journals and international conferences. Her current research is mostly based on NFV SDN-based network architectures with edge computing for vehicular system and the management and orchestration of flexible and programmable network services. So I would say that Nina is she was part in the creation of and in the deployment and development of this edge orchestration platform. So she is in the perfect position to present to us all the work that has been done. Before leaving the floor to Nina, just let me remind you that you can interact with us in any moment just by leaving comments in our social networks. So if you're connected to YouTube, LinkedIn, or Facebook, just drop a comment below the video. We will be able to see it. And at the end of the presentation, we will be able to answer your questions and curiosities. So without any further ado, Uh, I have the pleasure to leave the floor to Nina. Thanks a lot, Nina, for being here today. The floor is yours.
Thank you very much, Roberto, for the nice introduction. Hello, everyone. And today, as Roberto said, I will present the work performed in the 5G CARMEN project on the topic of advanced, secure cross-border and multi-domain service orchestration. This work is in particular performed by one of the technical work packages in the project, which is work package 4. And in this webinar, we cover different topics, but I first talk about the enablers of the Orchestrated Edges platform, which is in charge of service deployment, service continuity in very challenging cross-border aspects. And all of that to basically host and ensure service continuity for cooperative, connected, and automated mobility, or CCAM services. Then I talk about software design of our platform. What are the software components? What are the key design features that we enabled in the platform to ensure this type of secure cross-border multi-domain service orchestration? And of course, in the end, I talk about plans that we have for validating and testing this platform, which is the phase in which we are currently now. Aligned to these goals that I just presented for this webinar, we are preparing to talk about these several topics. I will first introduce you with the objectives and challenges that we faced, and of course, what are the goals that we wanted to achieve through the key design features that we enabled in this kind of orchestration. Then I talk more about the how this is obtained through the hierarchical orchestration and service management. Very important aspect of session and service continuity, and of course, also talking briefly about the security and privacy and data protection mechanisms in our platform. As I said, we talk also about the software design, about methodology of testing, and in the end, I will of course talk to you about the achievements and the remaining step in this project. Let's first start with the enablers. So with the enablers, we actually wanted to achieve the following objectives. Before I go to the objectives, let me briefly explain the figure on the right-hand side. So as Roberto already introduced the project, now you have an idea what the project is about. In this project, we have tackled very, very challenging scenarios where we have 3 countries, 3 MNOs, and we have service deployments that spans all 3 countries or different cross-border scenarios. We connect vehicles to these CCAM services that are deployed on the distributed edge cloud. And the role of this orchestration solution that we are building is to ensure that these edges which are hosting the applications are orchestrated, and to basically ensure the service continuity when vehicle is moving and needs to reattach from one network and one service to another. We did all of that having in mind the following goals. So we wanted to achieve some sort of very efficient resource management, because here we are talking about multi-access edge computing, which are not very resourceful in the end. And we also want to achieve very efficient multi-domain network service orchestration, because we talk about different domains, like administrative domains that belong to different countries, and also edge domains, which are then again available in all 3 countries. Of course, taking into account privacy, security, and all of that, we need to integrate all components into one solution for a cross-border system and run it all over 5G, of course, to connect the vehicles to the services and to run that in a very realistic pilot. So you can have some kind of idea of how challenging this whole framework is. And the role of the orchestrators is to have a full control over the resources in the edges, and to, of course, perform the lifecycle management of those services that are connecting through the 5G network with the cars. The main enablers for such framework, of course, are network function virtualization, multi-access edge computing, software-defined networking as well. So these are some of the pillars that we took and leveraged to enable orchestrated 5G edges. we didn't start from scratch. This is basically, these are standards that we focused on. So ETSIMEC, ETSINFW, and 3GPP. And I will come back to these particular standards in my presentation. I will refer to them and say where did we see the gaps and how we bridge those gaps to enable and enforce service continuity in such challenging scenarios. Let me talk about key design features that we had in mind when we were designing the platform. So we first started with several security and other functional and non-functional requirements for the platform. And from these requirements, we derived key design features that we want to have with this platform. So first, we want to achieve optimized lifecycle management of distributed CCAM services, which means that we want, in an optimal way, to perform, for example, deployment or instantiation of the services in different domains. We want to scale them in an optimal way. We want to terminate them when they're not needed, or importantly for service continuity, we want to relocate edge services from one domain to another, ensuring that connectivity is also achieved. So with that, actually that is possible to be achieved with the hierarchical edge distributed edge orchestration that we built. It consists of 2 layers of orchestration, top-level orchestration and edge-level orchestration. And I will come back to that later when talking about the architecture. But just to give you some sort of idea, like how we distribute the operations that are performed in this platform, and to enforce edge-level orchestrators, which are actually orchestrating the edge domains, to have autonomy in doing this. So with my next point, the delegation of man operations in this distributed and federated environment, management and orchestration operations are distributed, and delegated from the top-level orchestrators to the edge-level orchestrators by signing different management level agreements that I will also mention during the presentation. So basically, these agreements are delegating the decision to the edge-level orchestrators, allowing them to perform autonomously the operations on their edges, and also to collaborate with different domains that belong even to different countries and different MNOs. All of that is, of course, not enough if we don't couple with 5G system. And to ensure the connectivity with the vehicles that are the direct consumers of our services, we need to couple this edge system and NFV management and orchestration with 5G system. And this is what we enable in the architecture to basically allow our different elements in the architecture to interfere and to couple with the 5G elements in the 5G core, for example, and also other segments of the network. End-to-end mobile data plane control is extremely important when it comes to service continuity, because this mechanism enforces service continuity through adjusting different policies on the data plane control in the programmable data plane of our platform, and it steers the traffic from one edge to another, from one basically from vehicle to the target edge service that we selected for the deployment. But all of these concepts, of course, will be tackled later on in the presentation. I'm just sharing some main key design features now. Regarding security, we provided in this project some overlay security, not replacing the already existing 3GPP security mechanisms in 5G, but complementing to them and to basically ensure and provide some additional security on the edge infrastructure. Regarding multi-tenancy, in this project, you may already know that we have different car manufacturers and OEMs who are consuming, whose vehicles are using the services from the edge. And we also have different service developers that are deploying their applications on the orchestrated edges. So we ensure multi-tenancy in terms of isolating their services from one of each other if that's needed, of course. Service continuity enforcement is enabled through proactive orchestration decisions that are made on the deployment of services, and through these adjustments in the control plane, data plane control through the programmable data network and traffic steering. One enabler that is very related to the previous one that I shared is this enabling smart edges and smart applications. Smart edges is different from the smart applications because with smart edges, we enable our orchestrators to be smarter or to make more optimal decisions by taking into account different data and measurements that are being collected in the infrastructure and in the network as well. So basically here we are making decisions made by orchestrators smarter. And in the smart applications, we enforce applications to raise some very specific alarms or notifications for the orchestrators and control plane. And in that case, we are keeping orchestrators agnostic towards the applications. They don't know what is the specific operation that application is performing, but they're rather doing their job, but listening to the applications which help them to make better decisions. Let me go to the architecture now. In this figure, you can see the overall architecture of the orchestrated 5G Edges platform. On the top, NFV SO or NFV Service Orchestrator is the top-level orchestrator, which is running in the MNO core. It is not deployed on the edge, and we have only one NFVSO or top-level orchestrator per each country. The role and the position of this top-level orchestrator is to have a generic view on the edge infrastructure and the services that are deployed over there, as well as resources that are available. And it couples and it communicates and collaborates with other top-level orchestrators coming from different domains through this federated interface, which is OR. Other thing, of course, which is really important is that we don't want to burden this top-level orchestrator to do all the orchestration work and to take care about all services in all edge domains in one country. So that is why we offload the work to the edge-level orchestrators or allow them to perform the operations autonomously. How we do that? Through the management level agreement that I previously mentioned in the presentation. So these management level agreements are passed through the ME1 prime or adaptation layer. They are passed to the edge orchestrators, and basically through the signing of these management level agreements, edge level orchestrators are able to perform operations in their own domain. For example, for the CCAM services that are deployed on a particular edge in their own domain. In this way, this adaptation layer is also adjusting the differences that are specific for different layers. For example, we can have one software solution for the top-level orchestrator, for example, open source Mono, or have another completely other one for the edge-level orchestrators. And the role of this ME1 prime is to adjust those differences and to make them able to communicate and agree on different kinds of aspects of the orchestration. On this edge level here, we actually have two types of orchestrators. NFV local orchestrator is in charge of the lifecycle management of services with the help from Mac application orchestrator, which is making decisions based on different data that is being collected from the platform, from the overall edge infrastructure, and from the network. So they are helping each other and then collaborate through this LOLO federated interface directly with the other edge domains. This LOLO interface is a shortcut because if established during the management level agreement, then it can serve these edge level orchestrators to collaborate directly with the other edge domains without passing all the traffic and all the requests through the top level orchestrators, which are in the core. So let's go further. Regarding the edge system, here we have the overall NFV infrastructure that is used in the platform to host services and to manage them and orchestrate them. Not only CCAM services that are developed for different types of use cases, but also for MEC value-added services that are helping those CCAM services to, for example, disseminate messages to the vehicles and in general to communicate with the vehicles. This can be done through AMQP or GeoService. Then this, for example, value-added services collecting the different statistics from the radio network information. But CCAM services can be also directly connected to the vehicles, of course, depending on the type of the use case. And here, edge controller is very important, a binding element between the orchestrators and the edge system and or the edge platform. It is based on the ETSI standardization, but of course it is going beyond, because it doesn't only perform platform management and VNF management as stated and standardized, it also enables edge slicing here on the edge part by allowing different applications to be in different edge slices, defining different service requirements for each of them. And also, very importantly, it couples with the 5G system. In the project, and we don't have 5G standalone solution. We use in the pilot 5G known standalone. That is why we do this experimentation and this prototyping in the lab. And in fact, we do have interface towards the 5G control plane, which enables retrieving, for example, some configuration data about mobile subscribers, and also to retrieve different mobility events that can be further used to enforce decisions made by the orchestrators. On the other side, we have this N6 interface that configures and adjusts policies for quality of service or for traffic steering, for example, in case we want to steer the traffic from one edge system to another. The other point here is that Edge Controller also performs some very specific or customized networking for different types of services. And again, this is the extension on top of the standards that we mentioned previously. Regarding the 5G system, it is already clear that we use the 5G radio network and we use transport to connect through the network to the services running in the orchestrated edges platform. And regarding the security enablers, this intrusion detection classification module and identity management modules are making sure that operations are performed on the platform are secured, and that clients, which are basically vehicles, are authenticated, as well as CCAM services that they are connecting to. This is one example how these components can be deployed in different domains. Concrete example for the project, we have Italy and Austria, and we can have theoretically as many edge domains as we need. And of course, here we show one top-level orchestrator per each domain, and we can have as many as needed edge-level orchestrators. This is one decision, for example, made by these two edge-level orchestrators to migrate or relocate service from one edge to another, depending on different criteria that they take into account. And then they apply those decisions through the Edge Controller, and Edge Controller not only instantiates the service instance that is needed on this edge, but it also steers the traffic from the vehicle to this newly added instance. Let's go now to the lifecycle management operations. So this is the work that orchestrators perform, and by enforcing their decision-making with some additional notifications, like coming from the smart applications or coming from different monitoring reports, they can improve each of these operations that are provided here. So based on the management level agreements signed between top level and edge level orchestrators, we can have all these operations performed on the edge level. With instantiation, we talk about deploying service at least in one domain. For some services, we need to deploy 2 or more instances at the same time in different edges. And for example, for scaling, we need to scale out or we need to scale up depending on the needs, and if other resources allow us to do that. Migration or relocation, first we need to ensure that the corresponding instance is instantiated on the target domain. The selection of target domain is performed by the orchestrators, and once this is done, another instance is deployed on the target edge, and a vehicle can connect to the edge domain 2 when needed. This is a good introduction to my next slide, which starts talking about the service continuity. In the end, we have termination here, which is terminating service or releasing the resources if service is not needed anymore on the edge, so we can use services more efficiently for some other applications that are running over there. Regarding this session and service continuity, so we already know the reasons why we need it. So basically, we want to achieve session continuity not only if vehicles are crossing the border, but in case that they're crossing the border and there is a network reselection between different MNOs, we indeed need to improve or try to enforce this process to be as smooth as possible from the orchestrators. Basically, the network reselection is something that is out of our scope in this work package, and we're not tackling this part, but we are trying to mitigate this challenging handover procedure by performing different actions. So what we first do is to refer to the 3GPP session and service continuity mode 3. As you may know, in this SSC mode 3, 3GPP is standardizing the way of dynamically selecting the UPF or user plane function in the core network, or mobile anchor, is basically selecting the new UPF and steering the traffic between different UPFs so that user doesn't break the PDU session. However, since we have limitations in the production network in the project, we don't have this opportunity to work with a dynamic selection of UPFs, but we have a complementary solution for that. And what we do is to enable traffic steering through the programmable data plane. So once the decision is made to relocate the service from the edge orchestrators, we first instantiate the adequate instance of the service in the target domain, and then Edge Controller steers the traffic from the vehicle through this programmable data plane to the target service in the other edge. To summarize, what do we need to achieve that? As you may already see from the other slide, we need to couple our edge system with a 5G system. And we, in theory, will of course need to retrieve the event notifications to adjust policies on the programmable data plane. If that is not possible, we can also enforce those decisions from the orchestration layers, which are receiving different kinds of notifications and measurements from the architecture, from the overall infrastructure and 5G system. We need to couple edge management system with a programmable data plane through this N6 interface or this N6 reference point to enable data plane traffic steering. And of course, we need to couple edge management with the orchestration layers to proactively instantiate services when they are, even before they are needed actually in the target domain. Here I just briefly mentioned this architecture, 3GPP architecture for enabling edge applications, because this is the architecture that is being standardized, and it enables clients, in our case, vehicle clients, to discover different types of services that are deployed on the edge. And in this case, they are using these Edge 1 and Edge 4 reference points, which are dynamically created between edge applications and vehicles, to discover different types of CCAM services that are running over there so that they can connect to the ones that they are interested. We don't deploy this solution in our project, but what we do is take into account the main goals that this architecture wants to achieve, and we enforce that in the other way. So basically here, what we do is to enable vehicle to know the endpoint of the service that it wants to connect to in the CCAM orchestrated edges platform, and basically letting it know if this endpoint changes of the CCAM service, then vehicle is aware of that, so it can reconnect to it. Also, for example, to decrease the time of performing authentication procedure, we enforce this kind of communication between different edges, between edge orchestrators, so that security token can be transferred from one edge domain to another, from one CCAM service to another CCAM service, to basically skip that authentication step and to increase the performance of the service in that way. This comes to my last slide for this first part. So privacy, security, and data protection is, as I already said, further, let's say, improved on the edge part by enforcing different identity management module solution and IDCM, which can be deployed on any edge system. With that, we allow vehicles as clients and CCAM services to mutually authenticate. And with this intrusion detection classification module, we are securing the whole orchestrated edges platform by being actually very, very strong in terms of detection and classifying different kinds of threats that can happen in the overall system. This simulated in-vehicle intrusion detection system is further in a simulated environment, creating different kinds of threats that can be fed into this IDCM solution on the edge, so that it can improve its performance and be, not to be prone to different kinds of threats and to improve the security. Finally, I also mentioned here distributed ledger technology solution for RAN data sharing, which doesn't necessarily need to be deployed on the edge, but this is very important work because in this way, RAN data can be shared between different MNOs in the system. And by RAN data, we mean configuration of cells and base stations in the target domain where vehicle is going. And by then knowing what are the frequencies and what are the cells to which vehicle will connect once it reattaches from one network to another, the network reselection process can be highly improved, and the latency can be improved in this way, which of course we are targeting in the system to perform in a more efficient way. Let me talk a bit about the software design. So here, I'm not going to go in details how we deployed every single component in this platform, because we have very diverse environment. We have many partners who brought their components to the system, and you can even select different types of technologies to deploy and develop our platform. But we decided and agreed on several important principles. For example, we decided to have a cloud native principle in mind when developing all components and the platform, and we achieve that all pieces of software that we bring to the platform are containerized. A very important thing is that interfaces that connect our components and make them collaborate and talk to each other are developed in as open API REST-based interfaces. And I will refer you to the document where you can read more about all of these interfaces if you're interested in the end of my presentation. Open API or Swagger documentation is available for all of these reference points in our architecture. Regarding the overall platform, it is developed as a Kubernetes-based platform, and we deploy this Kubernetes clusters in different Mac platforms of all three MNOs. And all components that I mentioned previously are deployed as Kubernetes pods. And I also mentioned edge slicing as a very important added value in this orchestrated edges. And how we do this is to isolate different Kubernetes namespaces so that we can have Mac applications or CCAM applications in one namespace, value-added services in another one, and monitoring services is in the third one. And of course, this can be even further tuned, or you can have as many namespaces as you want. This figure shows one example of how different components in our platform communicate with each other. And as you can see, they mostly use REST APIs to communicate, but there is also another mechanism through the pub/sub, which allows orchestrators and adaptation layer or M1 prime to publish different notifications and data on this local AMQP broker, or to retrieve and subscribe to different kinds of notifications. For example, the ones that are coming from the smart applications, or informing top-level orchestrator about the operations that are ongoing on the edge level, so that it is aware of that. This is how the graphical user interface looks like for our top-level orchestrator. And due to the complexity and the thing that we want to hide the complexity of the end user, this is what we usually use when we demonstrate the work of the Orchestrated Edges platform. As you can see, we have 3 different dashboards for each of the countries that are affected on the Bologna-Munich corridor. And in this part, you can see basically in a very nice and illustrative way how to deploy services, how to send and offload and basically to upload the network service and VNF packages from the top level orchestrators to the edge level orchestrators, so they can further proceed with the autonomous orchestration. Here, the management level agreements are also defined, and if any change needs to happen, like you want to allow Edge Orchestrator to perform additional operation, these descriptors can be updated here, and this operation will be then enforced through the REST communication towards the Edge orchestrators. One very quick look to the Edge platform in Edge domain. So what we do have here is to show you different namespaces or edge slices that we create. For example, this yellow one is for Mac applications, and here we mentioned back situation awareness is one of the applications that we use for showcasing the work of the orchestrated edges. Here we have deployed another one, the Edge platform, and for example, in the third one, we are running monitoring services that are feeding orchestrators with different kind of data that they can use to perform their orchestration operations. Sorry. So regarding validation and testing, we have defined different KPIs in the project. But here I focus only on those that we define for this part of the work, for the orchestration and management of services. And we want to validate the work of this Orchestrated Edges platform because we want to see if there is an impact, which of course there is, on the performance of the services. To do that, we defined large lists of KPIs, and we divided them in several groups, like non-functional and functional ones. For example, we then further provide a granular view on the non-functional and functional KPIs. For example, depending on what they are measuring, are they measuring something in infrastructure or something regarding security or cellular or application related, and etc. And our strategy for this validation is following this criteria. We are dividing them to different levels of measurability, priority, also components that are involved in measuring, and measurement timing. Let me just give you some examples. So these are only some of the examples of the KPIs that we defined. And for the non-functional ones, you can see, for example, the runtime orchestration delay, which can be scaling delay. How long does it take for our platform to scale service when it is needed, either in one domain or in cross-border scenarios? Then, for example, we have this particular security-related KPIs that need to be measured. Also, component-associated delay, like how every component in the platform is contributing to the overall runtime orchestration delay. Then, localization gain, which is gain that is showing how successful is our platform in terms of enforcing orchestrators to autonomously perform orchestration in their own domains. And also application placement efficiency, which is showing how efficient the decisions from the orchestrators are when it comes to service placement and service relocation as well. And regarding functional KPIs, we have defined here only the ones that are very generic for any type of service. And like, average response time as a round trip time delay for the for any service that is running on the Orchestrated Edges platform. How long is service available? What is the quality of service? What is the throughput, and etc. So to be measured in an end-to-end way. In the end, we of course want to evaluate the impact of the non-functional ones to the functional ones. And this is what we are doing currently in the project in this phase of the validation and testing. Regarding the environments in which we do the tests, I already mentioned that we do the whole platform, let's say, related tests in the pilot. But also what we don't have here is, for example, some of the limitations in the network that we cannot test in the pilot. So that's why we create simulation environments and also lab to test those different proof of concepts. We have some work performed in the simulation environment, like using Omnet++ and NS3 based simulators. And in this particular work here, you can check more about the results that are presented here from our partners in the project. And something that I will focus a bit more in the upcoming slides is the application testing on the platform. I will give you examples of two different services that are deployed to support different use cases, like back situation awareness application and cooperative lane change application. They are both CCAM applications, but they are different because back situation awareness is the one that is deployed on demand only wherein there is a need for instantiating this type of service on the infrastructure, or like there is a emergency situation happened on the highway and we need to address that in an efficient way. Or the second one, which is cooperative lane merge in a centralized way, of course, which is supporting all the time the situations on the road that are to, for example, perform some lane change between the cars and etc. So to enforce, of course, to improve the safety and to improve the efficiency of those operations, we host these services on the edge domain. Back situation awareness, just a bit of context. In this distributed setup, we need emergency vehicle to connect to the CCAM service that is running on the Orchestrated Edge platform. And this is enabled through the CAM messages or cooperative awareness messages that service is receiving from the vehicle directly. And then further, the different kinds of messages like decentralized environmental notification messages or DNMs are sent through the GEOS service to different areas on the road so that vehicles can basically receive those notifications as warnings that they need to clear the lane for the emergency vehicle so that it can pass unhindered through this road. And very important aspect here is this direct data plane communication between different instances of the service. Cross-domain cooperation between different instances is very important because it allows this application that is running, for example, in Austria, to already know where the emergency vehicle is, what is its speed, and where it is going. So to prepare the vehicles that are in its own domain to clear the lane in a timely manner. So even before the emergency vehicle reconnects to this edge here, we proactively instantiate this instance and perform the operation as required. This figure shows how this back situation awareness is deployed on the platform, and I will of course not go into details how every functionality works, but what I want to show you is that it consists of several microservices, and it is again also developed in a cloud native way where all components are running in the Kubernetes pods on the Kubernetes platform in the Orchestrated Edges platform. We have several publications on this topic, and here I'm showing two of them, which you can of course reach and find out more about the results that we obtained both in the lab and in the pilot. I mentioned Smart Edge application feature. So this is very important because with this, we are enabling orchestrators to be application agnostic, and we are enforcing different kinds of decisions that can be made on the orchestration layer through very important insights from the application. To do that, we tested already in the pilot this feature for back situation awareness, where back situation awareness is raising notifications on the local AMQP broker, which then are used through pub/sub mechanisms on the Mac application orchestrator and NFV local orchestrator, which are then making the decision whether to proactively relocate the service or where to send a request for the complete relocation and etc. Regarding this centralized cooperative lane change service, I will give you just a bit of context how it works on the orchestrated edges. Same as BSEP, it is also deployed as a very, very complex service in particular, because this one is latency sensitive and it needs to run on the platform all the time. It consists of multiple microservices which are deployed in the same way as back situation awareness on our platform. And for example, what situation address is this green vehicle wants to overtake, and there is a red car which is driving very fast in behind, and we want to prevent any kind of collision, and we want this operation to be performed in a smooth way. So to do that, how is the CCAM service helping together with the orchestration? So basically, orchestrators are making sure that this service is deployed and that it has enough resources to run and to achieve the required KPIs, for example, in particular latency. Message broker here on the platform is collecting messages from all vehicles in the surrounding, and it is further fed to this server local dynamic map, which is creating contextual, extending contextual environment for the maneuvering service, which finds out about the situation, like where are the vehicles and what are the specifics of this kind of deployment. And then based on that, it creates vehicle-specific recommendations, which are further disseminated through the response router and message broker to the affected cars in this particular operation. Just to show you how the platform is deployed in all three MNOs, this is the figure we usually use in deliverables, so you can also check about it, of course, later on a bit more if you're interested. But these are all the components that are deployed on the platform, and how they communicate and what are different types of interfaces that we enable between different countries. Testing plans, we are already performing this, and in the pilot, we are doing both local and cross-border tests. And for the work that we cannot do in the pilot, we perform in the lab, of course. Let me summarize the achievements and what are our remaining steps. In my presentation, you could have seen that we created orchestration system, which is enabled to perform cross-border, multi-domain, and secure orchestration, and where all decisions are enforced through different kinds of monitoring services that collect performance metrics. And also, this platform tackles very important aspect, which is further improving and maintaining service continuity in cross-border scenarios. Regarding security aspects, we made sure that the platform has an overlay security and that all users are authenticated before they use CCAM services deployed on our platform. The main remaining steps in that will be performed in the final phase of the project in which we are now is to test and validate all the operations and all the aspects that I've been talking about today, and both including orchestration and security mechanisms. And importantly, we want to evaluate the impact of the non-functional or orchestration-related metrics on the CCAM service performance. But not only that, also evaluating the impact of security mechanisms that we provide there on the service performance as well. So this is all from my side. I hope you enjoyed the presentation. I give you more information here on this slide, so you can check different publications that we have. This is only a short list, but of course, you can check out more on the project site as well, and more to be found about all these concepts that I tried to briefly explain in this deliverable here. Thank you very much. I hope you have some questions for me.
Nina, thanks a lot for the very, very good presentation. Well done. So we have actually one question coming from the audience. I think it's for you, as it's specific from the presentation. It's from Yilma. Sorry if the name is not correct. And she asked, do you make edge applications smart because cars are not edge aware and cannot help here? And which information do you process in the edge applications to make them smart?
So this is a very interesting question, because the edge awareness of the cars in this overall system is a separate concept from the smart applications. Vehicle doesn't have information about the overall path through which it is driving. And edge applications, indeed, on the which are running on the edge, do have, because they are connected to different edge services that are running on different edge domains. So they have a broader view on the overall architecture and all the operations that are happening over there. So even if vehicle is edge aware, it is not aware of all different edges and what is happening on the entire route. So that is why we enforce further these operations by making applications edge aware and of course smart. But any case, it can be even improved if the vehicles are also edge aware, so they can help with different kinds of decisions. I hope I answered your question.
Thanks, Nina. Let me see if we have other questions. Don't be shy, just drop a comment on our social network. We will be able to see and answer in real time. Otherwise, I see one. So you said that there are, you have defined several KPIs and start doing testing and measurements. Is there any preliminary results available already? And if yes, where people can find this information?
Actually, yeah, Roberto, this is very important because now we are extensively measuring KPIs that I mentioned. Basically, I mentioned only some of them. And we do have some results, and we are preparing now the final deliverable in the work package 4. So I would refer everyone to keep an eye on the project website, because all deliverables will be available there, so they can find out about the takeaways that we derive from different measurements that we are currently making. Because now we are also measuring different operational activities in cross-border scenarios in only one domain, and all of that is done indeed in the pilot, and will be soon. I think in the upcoming months it will be available on the project website.
Thanks. Perfect. We actually now have more questions coming on. Very good. So another one we see is does offloading of orchestration to edges reduce load on the service orchestrator, or does it accelerate orchestration of edge application, or both?
Thank you very much for the question. So offloading of orchestration to edges indeed reduces the load, and this is the whole idea of offloading the load to the edge level orchestrators, because otherwise we would need to do all the operations for all edge domains and all edge services in one place on the top level orchestrator. And this, of course, increases the processing time and increases the processing delay on the top level orchestrators, which ultimately can affect the service performance. If it takes quite a long time to scale the service might be unavailable, and we know what happens then. Vehicles will not have connectivity to that service, and they will not retrieve very important information. Any other questions, Roberto?
Yes, we have another one coming from Francesco Paolucci. She congratulates for the presentation, by the way. And so he asked, how do you interface orchestrator with edge controller from the data plane programmable network? And how do you abstract network to the orchestrator?
Okay, very interesting. So first, we interface orchestrators with edge controller in the in a standardized way, how it is done in the 3GPP, in the ETSI NFV and ETSI MEC frameworks. There is a interface or reference point between the NFV local orchestrator and edge controller as platform and VNF manager, and this is the way how different decisions that are made at the orchestrator level are then passed to the edge controller to further apply those decisions and reserve resources, instantiate applications, and do the adjustments. And regarding the abstraction of the network to the orchestrator, this is very important because orchestrators do not interfere directly with a 5G system. They are doing this through the edge controller. And edge controller is enabling monitoring services that are collecting different statistics from the network, from the infrastructure, edge cloud, and this all information is then available to the orchestrators through the PEP sub mechanism. And basically by that, orchestrator is aware of what is happening in the network, but it doesn't really interfere directly with it. So everything is done here through the edge system and the edge controller. Thank you very much for the question. Yeah.
Yeah, thanks a lot. Thanks, Nina, really. So I think our time is almost done, so we have to close. I just want to use these few minutes I have to remember everybody that you can find information about the project on our website, on our social channels, and that all the webinars that we are doing are recorded. So you can see them on YouTube, on our playlist. Actually, we still have maybe one question that we can take is from Monica Luis Valdez. So how do you ensure service continuity for content delivery apps to users during transfer to a different Mac platform? It's important.
Yeah, in this content delivery apps, I assume these applications will have some state to be transferred, which is really important. And we do have some use cases that require services that, applications that are stateful. The example that I showed for the back situation awareness this is not the case. It doesn't have a state, but instead it has metadata to be transferred from one edge to another. But for content delivery applications, there is, of course, a need when you instantiate another instance on the edge platform, on the target edge platform, to also transfer the state through of course data plane connectivity between two different edges. And this is what we allow different service developers to test and use if they are delivering the content delivery applications as well. So this platform is not only covering those specific services that are talked about, they can be used for different applications as well. I hope I answered your question.
Yeah, I think so. So thanks again, Nina. It was very interesting for me, at least. And so you can see here the link to our website. We will do other webinars throughout the year. There will be another one in the second half of February. So stay tuned, follow us on Twitter and LinkedIn, and subscribe to our newsletter if you haven't done so that you can always that we can stay in touch and you can know what we are doing and when we are doing other webinars, and follow us. We are now in the last year of the project, so I expect plenty of news and information coming from us in the next month. Thanks again for your time. Thanks, Nina, for the very, very good presentation. It was a pleasure. See you next time. Bye-bye.
Thank you very much. Thank you. Bye.